Okay. Hi, and happy World UFO Day. Thank you for joining us in our celebration by learning more about UFOs. Tom Willmitch is a NASA Solar System Ambassador and Director of the Illinois State University Planetarium, and he will be presenting information on different UFO sightings and the potential of extraterrestrial life forms, followed by a Q&A.
All right. Well, hi, my name's Tom Willmitch. As was mentioned before, I'm a NASA Jet Propulsion Laboratory Solar System Ambassador. That, of course, is a volunteer thing. My full-time job is as the director of the Illinois State University Planetarium, where I'm also an astronomer, and I do quite a bit of observational astronomy, my work having been in eclipsing binary star systems. Well, anyways, it's to the stars we're going to travel today, or rather look at the possibility of life out there in the universe coming to visit us. And what I'm going to really focus on is how we look at this whole topic from the perspective of science. I'm not going to do popular culture stuff. I'll leave that to others to, explore aliens as perceived or as portrayed in movies. But I want to take a look at this from a scientific perspective, and also from the perspective of science. And what's the possible impact if we are visited? Of course, he didn't believe any had to date, and very few astronomers do, but or physicists or people in science. But anyways, there are a number of scientists that think, well, if we get visited, that might not be a good thing, and we'll explore that a little bit. Well, let's go ahead and dive into this. Let me bring up my presentation. Let's see, I guess we'll just click that. Okay, so are we alone in the universe? And again, from a scientific perspective, a little disclaimer to go with that NASA Solar System Ambassador position. As I said, that's a volunteer. Really reflect the viewpoint of NASA or the Jet Propulsion Laboratory. The opinions I express are my own. Well, okay. The perils from space. And, there is that. Why do we even bother putting up signs? Yeah. It's a risky business having a UFO land in your front yard. Well, okay. When it comes to UFOs, though, is there any evidence that we've been visited to date? And the truth is, in spite of all the press, all the publicity, and we have just been socked with it lately. We are in the midst of a UFO flap right now. These things happen every few years. You'll go years, and there's like nothing really to speak of about UFOs. You hear hardly a peep, and then suddenly you're deluged with UFOs news. But in spite of all that, there's really not a shred of physical evidence that we've been visited by extraterrestrials. And notice I just kind of pulled a little sleight of hand on you without even intending to. It's so easy to slip into it. I was talking about UFOs, unidentified flying objects, or UAPs these days, unidentified aerial phenomena. Well, let's just use UFOs for the most part. But things that you might see in the sky, all right, that you don't know what they are, and that is what they are. Things you don't know what they are, those are not necessarily extraterrestrials visiting the Earth. I equated the two, but you really shouldn't do that. Well, Carl Sagan, the late astronomer that was such a great spokesman for science, he said, "What counts is not what sounds plausible, not what we would like to believe, not what one or two witnesses claim, but only what is supported by hard evidence, rigorously and skeptically examined. Extraordinary claims require extraordinary evidence. And that's certainly true. We don't have any physical evidence to speak of, and certainly nothing that rises to the level that we could look at and say, this is technology from some other world. Now, that's not to say that I don't believe there are aliens out there. Carl Sagan was convinced that there was abundant life throughout the universe. That, though, was a matter of faith, a matter of opinion. It wasn't a matter of hard science. And Carl Sagan recognized that. He drew a line there when he would speak of such things. And he was asked about it quite often. I'll just leave it for you to read this little quote from Demon Haunted World, but it really goes to the heart of things.
Excuse me, Tom.
How good is the evidence? Yes.
You're not screen sharing.
Oh, we're not screen sharing. Let's go back. Oh, I'm sorry. That explains why nobody laughed at my jokes. Let's get that screen sharing up and running. I am so sorry about that. Let's see here. Which is it? Let's try this. And I'm going to take this right back to the very start. I'm sorry about that.
No
But
problem.
there we go. How about now?
Yep, that's perfect.
Okay, very good. So, well, I'll tell you something else. I didn't know I was a camera, although I guess I am in the corner there. But okay, so are we alone in the universe? The disclaimer, right? Don't forget this. These are my opinions. I speak for myself, not for NASA or JPL. And for that matter, I suppose, in a sense, not for the university either. I talked about the perils from space. Okay, here's what I was talking about. Having a UFO land in your yard. Yeah. Okay. And when it comes to Carl Sagan, I read this quote by the late astronomer. Just such a brilliant spokesman for all of science. And his book, Demon Haunted World, I cannot say enough good things about it. It was written in 1995 and re-released 2 years later by Random House. What a wonderful book. And it's as relevant today, maybe more relevant today, even than at the time it was written, just because so many of the things that Sagan wrote in Demon Haunted World have come to pass. Well, here's the quote I was referring to. That I said I would leave it for you to read for yourself. But the bottom line in this is, again, how good is the evidence? That's always the issue. Extraordinary claims require extraordinary evidence. And the important point that Sagan made. Well, okay. So let's take a scientific long view. We're going to ask a question. It was actually a question asked by Enrico Fermi, the father of atomic energy, you might argue. The University of Chicago physicist that won a Nobel Prize for his work back in the pre-World War II era and after the war as well. So where are the aliens? Well, Fermi asked that question back in 1950. It was when he was at Los Alamos National Laboratory, and it was in conversation with some other physicists. The question was almost kind of it was asked very lightly, lightheartedly during a lunch conversation. But he just blurted it out. They'd been talking about UFOs and a flap that had just arisen. This one, the whole topic was kind of a new one. And Enrico Fermi said, where are the aliens? He just blurted it out. Well, that has become a really perplexing question because we've been looking for aliens for like half a century now. We'll settle for any aliens. We'll settle for microbes in the buried deep in the soil of Mars. We're searching for those now. But the question is, where are those aliens? You'd think we would find some trace of some sort after such a lengthy search. But it was a good question back even in 1950, when there were all these claims suddenly of visitations from other worlds. Well, okay, why don't we, I think that should be fine, signs of intelligent life throughout the universe, since it seems so likely. And we'll get into that, why it seems so likely. There's a contradiction here, and we've got billions of stars in our Milky Way galaxy, somewhere between 200 and 400 billion stars. Sagan's famous billions and billions of stars, that famous comment from the original Cosmos series. Yeah, it's like hundreds of billions of stars in our galaxy. We know today that with those stars, there's like at least one planet per star out there, probably quite a few more planets per star. So just a phenomenal number of planets. And there's a high probability there are Earth-like planets out there. With so many of these stars older than the sun, you would think that by this time, our Earth is 4.5 billion years old, but the universe is somewhere around 14 billion. With the universe so old, so many stars out there, you would think there'd be advanced civilizations. And by advanced, I mean far advanced beyond us. And you would think that those civilizations, those alien civilizations, would be out there exploring our galaxy. There are proposals. We did a meeting here not long ago, a Zoom meeting. It was hosted by the Twin City Amateur Astronomers in Bloomington Normal. And we had a physicist, an astronomer with NASA, who was talking about like the projects they have going to send just tiny little sails. These things are like the size of postage stamps, but send them out to the stars. And being so small, they can get there in a decade, out to some of the nearest stars, just to sort of do it. Nobody's done that in our direction. We haven't seen anything like that. So, I mean, if we're on the verge of beginning to take these first steps, civilizations much older than us, I think they would have made some real progress. Now, the trouble is, though, that we don't find them. Even at the slow pace currently envisioned for stellar travel, like I said, our little solar sails, or well, stellar sails. I mean, we could, in a few million years, we or some alien technology could pretty much extend itself out through the entire Milky Way. Thing is, we don't see these probes. We don't see any sign of aliens. We don't see any sign of an impact through technology in other star systems. No, nothing at all. No trace. Not that we're finding radio signals. We're finding nothing. Well, that's kind of bothersome. Frank Drake, who was a radio astronomer, he led the first organized search for extraterrestrials using radio astronomy, searching for signals back in 1961, formulated an equation that we use today. And this is not this is not some kind of fancy, x equals y to the 10th power plus a times something. No, nothing like that at all. This is really just sort of a bit of reasoning put into a formal form. This is the Drake equation. And what we have is this quantity n. That's the number of technologies, advanced technologies in our galaxy. These are the aliens that could potentially visit us, or at least that are out there and have advanced civilizations. We're not talking about microbes on some distant world. We're talking about real civilizations with technology. Well, that number is going to be equal to, and then we have a number of factors involved. There's the rate of formation of stars in the galaxy. There's the the fraction of those stars that have planets. That's the second term. That's the F's of rho. There's the number of planets per solar system. Well, maybe I should have said stellar system, star system, but the number of planets that are in an environment that could sustain life. The habitable zone, sometimes called the Goldilocks zone. It's that special place at just the right distance from a star that life could exist. It's essentially where water could be in liquid form. The Earth is in the Goldilocks zone, with Venus and Mars on the fringes of it here in our solar system. Venus, not the nicest place to live, although if you go to the PBS Spacetime channel on YouTube, there actually are videos where they explore the possibility, and I know this sounds crazy, but the possibility of colonizing Venus, even though the surface of Venus has a temperature of like 900 degrees Fahrenheit. It might be a friendlier place than Mars. Weird as that sounds, but they explore that because Mars is not a nice place. And it's understandable that we're having trouble finding any signs of life on Mars. Well, anyways, what's the fraction of the number of planets that fall in that Goldilocks zone, that habitable zone? That's another factor. Yet another factor to consider when you're trying to figure out how many advanced civilizations are out there. And see, we're building to this final number. Well, what fraction of those habitable planets actually get organic life? There's another term in the equation, the fraction of habitable planets upon which intelligent life appears. You might have whole worlds where it's microorganisms, but nothing ever evolves to the point of intelligence. Maybe you have a planet where it's nothing but mushrooms or oak trees, or you name it. But what about how many of these worlds that do develop life, that are in the habitable zone, that are part of a star system that has a star that could sustain life? Well, what fraction of those planets get intelligent life? Then there's the question, I mean, until only a couple centuries ago, really the Industrial Revolution, look at where our technology was. Humans have been around for about 200 million years, but it's only in the past couple of centuries or so that we've had anything resembling technology. Certainly, it's only recently the technology that we have around us today. So what fraction of worlds develop life that in turn develops technology, at least technology that can be detected? When this equation was worked out, they really were trying to figure out what were the chances of finding aliens, that were sending signals into space of some sort that could be detected by radio astronomers. But again, this equation is much more useful than just that. So who gets the technology to send out signals to space? And finally, and this is actually a really important term, although it's one for sociologists more than it is for physicists or biologists. And you can see what's happening here. There's terms that are really astronomy focused. There are terms that are focused more on biology. But this last term, this L, it's the length of time those civilizations send out signals. And that is really an important term, as it turns out, because as Carl Sagan pointed out when speaking about the Drake equation, it could be that every civilization, all these aliens are going to at some point discover the atom and how to split it and how to make nuclear weapons. And the question is, do they survive that? Is it inevitable at some point some madman on each and every world out there in the galaxy, some madman gets his tentacles, his hands, his paws, his whatevers on a nuclear weapon and blows the place to smithereens? Is that why the universe is silent? Is that a threat that we face? Or what about climate change? Climate change, another threat to us. Polluting our planet, whether it's through climate change or other means, are we going to wipe ourselves out? Does that happen to everyone? Well, like I said, these are more social questions for sociologists than for biologists or astronomers, but it's an important factor. It's a factor in the Drake equation. So these are all things we need to consider. There have been just countless scientists, astronomers, biologists that have plugged numbers into this equation that try to come up with an answer. Science writer Keith Cooper put together, he came up with a bunch of numbers. He looked at our solar system, basically. He assumed that the rate of star generation in the Milky Way was one solar mass, one star per year. Yeah, that's about right. Maybe actually a little on the low side. It could be as high as 3 or even 5, but yeah, the number's about that. Where gas out there in the Milky Way galaxies, great clouds of gas laced with dust, these nebulae collapse on themselves and form in the stars, and then planets form around them. And it's about one to 5, somewhere in there, per year. So he used 1 as the number. He looked at our solar system and said, well, stars with planets, well, 1 in our case, right? Our sun, it has planets. The number of planets in the solar system that could have life. In our solar system, there's the Earth has life, pretty sure. I've got a window right in front of me here, and I see things out there that are moving around. I hear birds, there's life. Okay, so the weak anthropic principle being applied here. The idea that, we're in a place that could sustain life. Thus, we're here to see that we're in a place that sustains life. Sounds like a tautology, but it's not exactly. Anyways, okay, so there's the Earth. Maybe Mars has life. We know Venus doesn't. It's way too hot. And there was like a little bit of stuff in the news a while back that maybe they found traces of some markers for life in the atmosphere of Venus, but that seems not to have panned out. Anyways, Mars, well, maybe there's life down there in the soil. We're currently searching for it. Europa, one of the moons of Jupiter, it has an ocean beneath its frozen surface, an ocean of liquid water. So there's the potential of life there. And in Enceladus, one of the moons of Saturn, it's the same story. So, there's four worlds in our solar system that might have life. The fraction of planets where organic life actually appeared in our solar system, just 1, the Earth. So that's a quarter to put in that equation. The fraction of inhabited worlds where there's intelligence, well, okay, I know lots of jokes about that, but 1 in our solar system. There is intelligent life here. There's you're intelligent. The fraction of civilizations that could actually send signals into space, we're doing it. Whether it's I Love Lucy shows that are slowly working their way farther and farther into space, those signals getting pretty garbled, pretty diffuse, but that or actually transmitting signals out into space using telescopes like the now, unfortunately, it's a loss, but the Large Radio Telescope at Arecibo in Puerto Rico, that was used to transmit signals on purpose out into space for other civilizations to find. We got a 1 for that value. And then finally, well, we've been around 100 years anyways, or hopefully we'll have 100 years of sending out signals. So if you plug all this stuff into that equation, yeah, you come up with something like 100 civilizations out there in the observable part of the Milky Way. Is it 100 though? Who knows? There's strong arguments that it's close to 0, maybe 20, where other researchers, they've hit numbers like 100,000. You can basically make any argument you want with the Drake equation. and find numbers to support where what your opinion going in is. Of course, that's not the way we want to do things in science, but yeah, you got to start somewhere, right? You have to start with some assumptions, being willing to discard those. Don't hold too dearly to your beliefs. And you know, everything I'm saying, by the way, an alien could land outside my window. It could be like in that picture that we started with Ma and Pa sitting on the porch. That could happen in the next 5 minutes. And boy, my opinions will change sharply if that occurs. Well, anyways, yeah, you could get any old number you like in the Drake equation. Still, we keep coming back to Enrico Fermi's question, where is everybody? You would think whether it's 100 civilizations, that 100,000, you know, the universe, our galaxy at least, the observable universe for that matter, should just sparkle with signs of life, and yet we find nothing. Well, how do you explain that? There are ideas bouncing around. One of them, one of the more popular ones among scientists, is known as the rare earth hypothesis. It speculates that we're in a really unique piece of real estate, far more than you might expect. We're in the right location, in the right kind of galaxy to support life, the life that we see when we look out the window or even in a mirror. We're at the right distance from the right type of star. We're in that habitable zone. The planets are in the right arrangement. Well, what's that? It sounds like astrology there. No, it's astronomy. The planet in particular they're talking about is Jupiter. Jupiter's in a really great position to sweep up any debris, be it comets or asteroids or what have you. The sweeper deflect those things so that they don't come plowing into the inner solar system, to the smaller terrestrial, the Earth-like planets, and into the habitable zone in particular. Oh, you know, where Earth has been struck by asteroids in the past, it will be struck by asteroids in the future if we don't safeguard against it. When? I certainly can't say. But the point is that Jupiter protects us. It does a lot. So yes, the planets are in a right configuration in our solar system. Of course, the planets have to have stable orbits. If you had a double star system with planets going around 2 stars, you can imagine how crazy those orbits would be. And eventually those planets either are flung off into space or fall into the stars. Although we have recently found one example, as I recall, one case where we actually have planets in a stable orbit in a binary star system. But what that is, the one star is really distant and its influence isn't great. Anyways, the planet has to be the right size. It has to have plate tectonics. I won't go into the details for that, but it has to have the strong magnetic fields the Earth has to protect us from radiation from space that's deflected by, you know, energetic particles from the sun. The solar winds are deflected by the magnetic fields of the Earth. That's what produces the northern and southern lights, the aurora borealis and the aurora australis. Here's a really critical one. This one could be like if you're going to list these in order of importance, pretty much at the top of the list. The planet must have a large moon. It turns out that the tidal effects of the moon are critical to the way the Earth has evolved. Everything from those strong magnetic fields to the impact, the influence on life from a biological perspective. The moon has played a major role. You need that moon. The moon, by the way, well, a chance thing. It was when the Earth was forming 4.5 billion years ago that a rogue object in the solar system, you know, maybe a forming moon around another world, another planet, it came our direction. It was the size of Mars. It slammed in the Earth, and from that we ended up with our moon. That's our best hypothesis today. So the moon, really unique. You have to have the right kind of atmosphere. Evolution has to trigger complex life. The planet, it's at the right time in its evolution for us to be here. All these things happen with the Earth, and it might be, again, exceptionally, just incredibly, phenomenally rare that this happens. The Earth could be a really unique spot. That's the rare Earth hypothesis. I don't know if I buy it or not. I mean, that's a lot of stuff in there that I don't know. I'm not completely sold on it, but maybe. Well, okay. Who cares? That is, of course, a good question. I mean, all right, we're here. Isn't that just good enough? Well, I've already alluded to that final term in the Drake equation. So, and again, think about Enrico Fermi's question. Where are the aliens? Why don't we see any trace of them? That's a little worrisome. What's going on there? And does that mean bad news for us? We do care. Here's the problem. When we look at the Drake equation, first off, those high numbers, they're pretty iffy. The low numbers are probably what we're realistically working with. And there is something in statistics known as the overconfidence effect. When you don't have a good handle on stuff, you tend to guess high. It's just a human trait. And so we know that. So probably those low numbers are the better ones. But there's really a far deeper problem. Even if there's not a lot of alien civilizations out there, is there a great filter? Is there something in all the steps it takes to go from a star system forming, forming its sun and its planets? Is there some step along the way from that to having intelligent life exploring distant stars? Some filter that suddenly eliminates that life, keeps that life from happening, or snuffs it out. That great filter is the big concern that a lot, the majority probably of people that think about this, it's what they worry about. It is what keeps them up at night. The great filter hypothesis was first proposed back in '96 by Robin Hanson at George Mason University, an economist. Yeah, it was an economist. Remember I said there's social factors involved in that L term, that final term of the Drake equation. And even economists look at this. After all, if aliens are out there and they're exploring the universe, why are they doing it? Maybe curiosity, but they could be looking for raw materials. If aliens show up on our doorstep, it might be like, the 49ers invading California back, a couple of centuries ago now, or it could be rough. I mean, it could be bad news for the inhabitants. There's a long history of people behaving badly when they are looking for raw material, when they're colonizing and they encounter native inhabitants. A long history of that on our world. And there's no reason to think if there's aliens that it's not the same thing. This was the concern of people like Stephen Hawking, who was so worried if we did encounter aliens that they would not be particularly friendly. Remember that episode of the Twilight Zone, not the Outer Limits, the Twilight Zone, To Serve Man. The aliens show up and they're bringing all these wonderful gifts, and we get hold of one of their books and we're able to decode. We figure out their language just enough to read the title. It's To Serve Man. And it's like, wow, this is absolutely wonderful. These aliens are here to help us, to be guiding lights for us, to provide us with technology. And so people are boarding their spaceships, flying off to their world, and being taken to their world. In the very end, though, the linguist who's deciphering the book To Serve Man, he discovers it's a cookbook. Well, that's the worry here. So, anyways, getting a little back to it with the great filter hypothesis. Okay, we have a handle on the physics in astronomy. I mean, we have a really good handle on star formation rates, thanks to like the Kepler Space Telescope that has surveyed world after world after world. We have a good idea of the number of planets out there. Even like I mentioned, the Twin City Amateur Astronomers, they have a marvelous observatory here in the area that it's a small university level observatory they maintain. And several of the telescopes are capable, at least, of doing survey work looking at planets crossing the face of distant stars. We could do exoplanet studies. That's something amateurs are doing for working with the American Association of Variable Star Observers, the AAVSO. So, I mean, we got a good handle on the astronomy end of stuff. There's certainly a lot of questions swirl around the biology. We don't know, for instance, how life began on this world. We just don't know what was the spark that started life, even though we have a reasonably good handle on how life has evolved since that beginning. But the beginning itself, that origin, a lot of questions there. And of course, that's critical to this. And of course, there's the social workings, the evolution of societies. Do they go out there and are they tamed? Do the better angels of their nature dominate when they go to explore other worlds? Are they out there to colonize? Do they blow themselves up before they ever get anywhere? You know, we just don't have a handle on this stuff at all. You know, we've never met an alien. So this actually is important. I know it's a little wordy here, but I'm going to just sort of tick through this quickly. This deep dive into the Great Filter. The Great Filter assumes that there's a series of steps that anyone, everyone, every alien civilization has to progress through to go from just a rock orbiting a planet, or even the rock being there, to the point where they're traveling out in space. There's steps that just logically we have to move through each of these steps. These are the ones that were first devised by Hansen with the Great Filter hypothesis. You have to have the right star. I mean, yeah, I keep harping on this, but you got to have the right star system. Okay, it has to have the organics in place. There have to be planets in the habitable zone. Okay, so you got to start with someplace. You can't just be drifting in space. Reproductive molecules, RNA, has to develop on one of those worlds. Simple single cell life has to develop. From that, complex single cell life. And that's a big step, by the way. That's no minor thing, making that jump from step 3 to step 4. Sexual reproduction must develop. You got to move beyond just single cell stuff. You have to invent sex. Don't you know it? Sex gets into everything, even this talk. Well, okay, sexual reproduction has to develop. Multi-cell life has to arise. That multi-cell life has to eventually become a creature that can use tools and develop, if they're doing that, intelligence as well. I mean, humans are not the only creatures that use tools. There are lots of animals, but none of them are quite where we're at. That civilization has to develop the potential to explore other worlds. And we're taking those first steps. You know, NASA or someone is going to send stellar sails and little microchip size probes riding those sails out to the stars. And we'll do other things as well, I'm sure, over time. So we're on the brink of doing these things now. Then finally, an explosion of colonization must happen. Just as the West, was suddenly explored, there was just a burst of colonization. It seems it's predicted that that's going to happen. It'll be driven by the need for resources, for raw materials and the likes. We'll start by mining the moon. We'll mine asteroids. We'll mine the moons of other worlds. By that I mean other planets, Ganymede or where have you. We'll start with those things, but we could eventually even move out beyond our solar system, being driven by population numbers and by the need for resources. So number 9 has to occur. And that's where you get to the point where you're going to see, or somebody else will see us. We should be seeing those aliens. Enrico Fermi's question, where are they? Well, this is why we think we should be seeing them even now, because it's speculated by people like Hansen that, yeah, there's been enough time that if somebody got a head start on us, if we're not the first bit of life in the universe, which is possible, maybe there's people, creatures trailing behind us, other worlds that are at the low numbers on this, trailing behind us. But anyways, if we're not the first, we should be seeing others. Well, okay, so we know we've here on the Earth, we've gone through the first 8 steps. But we're not finding anybody else. We're looking. The question is, though, all right, and I'm going to be a little time conscious and not, tick through all this, but okay, we know that the first 8 steps have happened here. What happens with the 9th step? Do we colonize are we the ones to colonize worlds? Or are we going to, through madmen with nuclear weapons or climate change or polluting our world, are we going to take ourselves out of the game? We don't know. But we know we've gotten through those first 8 steps. The problem is when we look at that 9th step and whether other civilizations have gotten through this dangerous stage that we're currently in, this adolescence with technology. We don't know if the problem with the Great Filter is the earlier numbers, those earlier steps. Maybe some of those things with the biology, some of those factors with the biology just are much more difficult to overcome than we realize. Maybe single cell life moving to the next step. Maybe that's just so rare that nobody gets to where we're at. And that's why we don't find aliens. Then again, and that would be good news for us, right? Because that means, yeah, we got the potential to get through this adolescence we're currently in with technology, to solve our problems of technology with technology, and to move out to the stars. It's good news, okay? What's bad news actually is if we find simple life elsewhere in the universe, but nobody advanced in front of us. Even if we find life at about where we're at, we don't know that they can get through that adolescence any more than we can. But do you see the problem here? We just don't know where the Great Filter falls. If it's somewhere in the first 8 steps up to where we're at and we got lucky, or is it in the 9th step, in which case, since we don't see aliens out there, the odds are really against us, which means we have to be really conscious. We have to be really careful when it comes to our environment, when it comes to weapons of mass destruction, when it comes to global warming and issues like that. We have to really, really be on top of those problems if we're to get through, make it to that 9th stage. Just moving through this a little more quickly at this point. I know it's all been aliens, but what about them coming to visit us? Well, just briefly, space is really big. There's also a cosmic, Albert Einstein found that there's a cosmic speed limit out there. And maybe there's some clever methods to get around that cosmic speed limit. But it seems like the cosmic speed limit, putting this a little glibly maybe, but the cosmic speed limit is the speed of light, 300,000 kilometers per second. 186,000 miles per second. I mean, that's so fast. Light goes so fast. If you could bend it, it would zing around the Earth's equator 7.5 times in a single second. Light really moves, okay? But when you're talking about the distance of stars, kilometers, miles, they don't work well at all. What we use instead is something called the light year. A light year is the distance a ray of light travels in a year's time. That's about, it's almost, well, it's 9.5 trillion kilometers, almost 6 trillion miles, okay, is one light year. To get out to the stars, well, the next nearest star after the sun is Proxima Centauri, 4.2 light years away. That's about 26 trillion miles to the next nearest star after our sun. Oh, the sun, by the way, you don't use light years to get to it. It's light minutes. The sun's about 8.5 light minutes from the Earth. So, okay, the bottom line, space is big. The Milky Way galaxy, wow, look at that, down at the bottom, that diagram. The Milky Way spans 100,000 light years, going the speed of light, 186,000 miles a second. It would take you 100,000 years to cross our Milky Way galaxy. And with upwards of 400 billion stars, yeah, any one star, a needle in a haystack. So maybe these are the issues that have caused us to not find aliens, or for that matter, aliens that might even be looking for resources and us. Well, us and resources, maybe I should say. Anyways, yeah, maybe it's hard just to find anybody with space so big, distances so great, and such. Matter of fact, that leads to another possible great filter. You know, maybe the great filter is crossing space itself. Maybe the reason nobody's colonized the universe, well, I should say the Milky Way galaxy. Maybe the reason nobody's colonized it, it's a lot harder to cross space maybe than we realized. Maybe the interstellar medium, the space between the stars, where we find gases and interstellar dust, and maybe that is a lot tougher to cross. I mean, to physically travel through than we realize. Well, okay. Keeping an eye on the time. I do want to demonstrate. I want to talk a little bit. You know, we've got this current UFO flap going on, and let's just see if this works. I'm going to try running a video for you, and let me know if this plays all right.
The monkey business illusion.
I'm going to start.
Count how many times the players wearing white pass the ball.
So watch that ball.
The correct answer is 16 passes.
How'd you do?
Did you spot the gorilla?
Oh, yeah, and the gorilla.
For people who haven't seen or heard about a video like this before, about half missed the gorilla. If you knew about the gorilla, you probably saw it. But did you notice the curtain changing color or the player on the black team leaving the game? Let's rewind and watch it again. Here comes the gorilla, and there goes a player, and the curtain is changing from red to gold. When you're looking for a gorilla, you often miss other unexpected events.
You know,
and that's the monkey business illusion. Learn more about this illusion and the original gorilla experiment at theinvisiblegorilla.com.
when it comes to this current UFO flap, you know, we're dealing, okay, we've got these videos. I'll say a little bit about them. Probably I won't have time to say as much as I'd like. But when it comes to UFO sightings, humans are poor observers. It's as simple as that. How many of you, if you never saw that video, how many of you saw the gorilla? Ask yourself. Probably about half of the people out there did see the gorilla, but about half didn't. And the curtain change, the color in the curtains, the player leaving the game, all these things are happening. Probably didn't see them. And yet you were watching, it's just your attention was focused elsewhere. We're poor observers. Elizabeth Loftus has done a lot of work with this, and you can on your own go out and just explore the topic of eyewitness testimony. It's terrible. If somebody's convicted with just eyewitness testimony in court, heaven help that person, because they could be innocent. It's terrible. When it comes to our perception of things too, and this gets into how we perceive the world. It's an important factor when we look for UFOs. We've got things like this lady. What's the deal here? In one picture, she's tiny. In the next picture, she's huge. And there are no camera tricks here. This is known as the Ames room. And here goes what's happening. That's one wild wall that she's standing in front of. She's the same size in both pictures, but it's the wall that's shaped crazy. It's got a crazy shape to it. But if you're seeing things from the wrong perspective, you can totally misunderstand what's before your very eyes. Your eyes will lie to you. I just love this thing here, the Herman grid. Look at the little dots. See how they move around as you look at this? Yeah, wild. Huh. Oh, and here, this is important. This relates, and again, I don't know if I want to take the time to do it or not. I'm going to pass on this. But if you go to Mick West's YouTube channel, Mick, M-I-C-K West, he has a YouTube channel, and he shows the parallax effect. The Go Fast video released by the Navy that shows the object right above the water and the water is zipping below it, he does something similar in the video where it turns out the object's not even moving. It's really crazy, but it's a parallax effect. You know what? You can do a simple experiment as you're sitting at your computer right now. You can hold a finger in front of your face, close one eye, and then just simply watch your finger, keep it centered in your field of view, move your head to the side. Now your finger didn't move at all, but notice how the background zipped. And yet if you didn't realize that it was because your head's moving, that background moves, then you would think that your finger was moving quite fast. So that's the effect you're actually seeing in the Go Fast video. Context is everything. Yeah, it really is. And one big thing when it comes to UFOs, if you don't know how big something is, it's impossible to judge its distance. Using the binocular vision that we have, our eyes separated by a little bit so that we get a parallax effect that our brain uses for calculating distances, that only works out so far, not to a really great distance. And if something's off in the distance, even in the daytime, not less at night, yeah, you just, if you don't know how big it is, you can't judge the distance. Oh, and inversely, if you don't know the distance and you don't know how big the object is to begin with, well, you're stuck. You don't know the size, you don't know the distance. It could be something small nearby, it could be something large far away. Both will look the same. It's actually a classic problem for astronomers trying to figure out, like, are all the planets the same size? What are the distances? Or I should say stars. Are they all were they the same size? Are they the same size? Are they at, like, what are the distances to them? If you don't know their brightnesses, it is a classic problem in astronomy that took centuries to work through. Here's a bit of an illusion when it comes to the sky. Which of those planes is higher? Plane A or plane B? There they are. You can see them at the end of their contrails. Well, let's see. Let's just move back in time a few moments. In seconds earlier, there's plane B flying below plane A in its contrail. So a lot of people think that A, because of the just, again, you don't know the sizes, The smaller plane B and the angles involved, yeah, it throws the eye off. A lot of people would have said A, but B's the one that's lower. When it comes to unidentified, try that again. And I should say UAPs, UFOs, unidentified flying objects. Yeah, they're just that. They're unidentified. Most of the time, you know, there are reasonable explanations for them. Oh, and on the left, that's those cursed SpaceX Starlink satellites. They fly in formation. That wasn't like a time exposure. You can actually see these things. SpaceX plans to put upwards of 30,000 satellites in the orbit around the Earth. Little tiny guys. I think it's just to vex astronomers and stargazers. Beautiful example of a sundog in the other image. And you see those around here all the time in Illinois. I'm not going to take the time to talk about type 1 errors, but we're inclined to be a little fearful. Thank evolution. Thank the lion hiding in the bushes. Our ancestors, the ones that were jumpy and ran away when they heard a bush rustle, they're the ones who lived. Maybe it was just the wind, nothing to run from, but the ancestors who didn't run, and it turned out it was a lion, yeah, they got ate. You're not descended from them. You're descended from the ones who ran away. And that causes us to give agency to things. When we hear a rustle in the bushes, we think there's something moving in those bushes. It's something that's thinking of eating us. You know, we put agency on things. And that goes back to type 1 versus type 2 errors in psychology and all of that. As far as the government goes, yeah, we've had projects. There was Blue Book, well, Grunge, and then Blue Book. There was the Condon Report. You know, these things led astronomers and physicists and scientists in general to have kind of a low opinion of UFOs. Nothing has ever really worked out. That's not to say that things aren't worth watching for. And this UAP report from the Director of National Intelligence, it's an important report. Does it find UFOs? No, it doesn't. I won't go through all these points, but no, they don't. They know where. Well, okay, let me be clear. They do find in the report that there are unidentified aerial phenomena. Are they extraterrestrial in origin? The report does not ever find that. What they find is that there's stuff that's hard to explain. It could be airborne clutter, it could be natural phenomena, it could be U.S. government or U.S. industry developmental programs, things like drones or experimental aircraft. It could be foreign adversaries. Maybe they're launching drones from submarines to follow our fleet. Who knows? I mean, and see, that's the trouble. We don't know. We don't know what these things are. Are they faulty equipment? Do we have defects in our surveillance equipment? Are we poorly training the military personnel that operate that equipment? All these are important things because, you know, if we're seeing stuff and we don't know what it is, we need to know. Now, is it alien? There's no reason to believe that. That's quite a leap. After all, there's no sign of aliens. I mean, from like the science perspective as we've explored. So that's a bit of a leap, but you know, we're certainly seeing something. So what is it? We need to understand why we're seeing things that we can't explain. It's important for national defense. So yeah, it is important. And this just goes through some of the points I made. What are misidentified as UFOs? And we're getting close to the time where we're going to have to wrap up my presentation, but let me just show you some of these things. I'll just run through this very quickly. Things that are mistaken for UFOs: aircraft, including now drones. Those little guys, they really like to show up in unexpected places, it seems. Balloons, don't laugh at those. Adler Planetarium over the, not, was it, I'm trying to think, it was not this past summer, the summer before, not the pandemic summer, but the summer before. I had somebody that worked for me in the planetarium, worked for Adler over the summer, Adler up in Chicago. And they were down in your neck of the woods, down around Springfield, doing a summer camp where they were actually launching weather balloons. There are all kinds of weather balloons. There's sky lanterns. You even have people that are jumping at night, doing, parachuting at night, and they have lanterns and lights. They do it in formation sometimes.
Where did he go? He's gone.
I don't know. Tom, are you still there? Oh, I think it kicked him off.
Maybe he'll log back in.
Maybe. Let's give him a minute.
Yeah.
Hi, Tom.
Yeah. Hi. It seems like I lost you for a moment there.
Yeah.
Well, let me just sort of wrap this up, if you don't mind. Let me make sure I'm screen sharing here. Oh, boy, I need to take this back to where I was. Okay, here we go. Yeah, I'm not sure what happened there. We had a little technical glitch. I think it was aliens. They didn't want us to get the word out. Just some other things quickly. Those SpaceX satellites re-entering space debris, that Chinese booster rocket. Oh, I love lenticular clouds. Weather phenomena, including lenticular clouds and sundogs. Oh, and sprites. Those things are wild. I have never seen one. I would love to see a sprite. And I watch the sky all the time. I think you need to be up near the poles for that. And then things like the things I know so well, fireballs and meteors, bright stars, planets, particularly Venus. Venus, if you have thin clouds, Venus is amazingly bright at times. If you have some thin clouds that you're seeing it through and those clouds are moving, it gives you the feeling you're moving. It's really wild. And of course there are hoaxes, but I don't even dive into those. As for weather balloons, here's some examples. Notice that one in the upper right-hand corner. Yeah, that if I looked up in the sky and saw that little thing, I'd be really, and that's how it would look through binoculars. I would just be creeped out. That looks so weird. But that's a weather balloon. The Go Fast, by the way, if you work through the Go Fast video, it turns out to be a weather balloon, a small one, only about 6 feet across, moving at about 40 knots, half the height above the ocean between the plane and the ocean surface. I think it was like 14,000 feet, something like that. Here are those injection tests that the NASA was doing. I don't know if they're doing them right now. They used to launch those from Vandenberg Air Force Base in California, and we used to watch them here. So, I mean, you could see these across the country. Some really wild looking things, and they were beautiful to see. Very bizarre though. If I didn't know what they were, I'd be kind of spooked by them. Well, that center picture in the bottom, that's SpaceX's vision of the future. There are 30,000 space-linked satellites. But like I said, they're in trains. That is a snapshot. That's a single snapshot in the upper left-hand corner. You can get a whole bunch of these things all in a row moving across the sky. Missile launches, that's a Russian missile launch in one spot there. Some SpaceX stuff in the other images. kind of creepy looking. The weather phenomena, I love sundogs. I think I have never seen the lower one, the one directly 23.5 degrees below the sun. I've never seen that lower one, but I have seen what you see in that picture. I have seen everything but that twice. I see sundogs all the time. I bet you once every couple of weeks at least, probably more often around here. But to see all the rainbows way off to either side of the sun, the pair of 23.5 degrees, little rainbows, the circumzenal arc at the top of the sky. Only twice have I seen that. It's kind of rare. Those lenticular clouds, so I love those things, and I do see them from time to time here. Boy, those look like UFOs. And there's a sprite. There's that thing that looks like a jellyfish. That's like lightning. Those things are really poorly understood, but they're well observed. And finally, astronomical objects. You know, the things I mentioned, Venus. That's actually that big fireball over the asteroid, the fragment of an asteroid that came in over Russia in the bottom of that frame. That shattered windows. Lots of people were hurt by broken glass. Let's see, I'm just going to move to the resources here. I'm not going to, because of time constraints, we've run a little over. I'm not going to say anything more about the videos, but you'll see listed here the very last thing, Mick West's YouTube channel. Go over to that YouTube channel. He takes the Go Fast video and takes all the stuff that's on the screen, on the recording, the recording of the screen, the military screen. It has all this data on there. It has the camera angles, the altitude of the plane, the speed of the plane, the headings, how the plane is turning. All that information is there. He works through that. And he actually does the trigonometry and calculates. It gives the distance, by the way, to the object in the Go Fast video. It's actually stated the distance. They measured that. He works through all that and shows it has to be probably a weather balloon. Whatever it is, it's about 6 feet across. It's about half the height of the plane above the surface of the ocean, puts it at over 10,000 feet. The object's about 6 feet across. It's all in the video if you'd read all the numbers. What's the mystery there? There's nothing. The weird glowing thing that's tumbling, that's an infrared image. You're seeing the afterburners of a distant jet. The tumbling is a result of the gimbals in that stabilize the camera.
Others to explore aliens as perceived or as portrayed.
Ghosts in the machine. But there's other resources there. I mentioned Carl Sagan's Demon Haunted World. Phil Klass, the late Phil Klass, wonderful gentleman. I knew him. I used to live outside of DC, and he was in Georgetown. He was just the greatest guy in the world. He was for many years the top science studying, the top guy that studied UFOs from a science perspective. And although those books are a little dated, they certainly do a wonderful job looking at all the classic cases of UFOs up until the time those books went into print. Phil Klass was an engineer with General Electric. He helped to create the gun turret, the automated gun turret on the B-29 Superfortress bomber from World War II. Other resources, though, the Center for Inquiry. If you're interested in how you misperceive the world, the You Are Not So Smart website, it's full of all the ways the human mind tricks the human mind. And of course, Metabunk. Metabunk it goes through all these UFO things, along with Mick West is one of the key guys, but not the only one at Megabunk. And they go through and just analyze. That's what they do. They analyze UFO videos and sightings, and they work through the most probable things. And they're open-minded about it. Mick West emphasizes that. If you see something, don't discount the possibility of aliens, but that's kind of the last place you're probably going to go. Well, okay. I don't know how we are for questions. I'm open to take whatever you might want to field in my direction, or how do we want to tackle that?
Rachel, go ahead.
Hi, thank you for this really great presentation. I'm wondering, because I've seen some stuff online that was like, maybe we never received any radio transmissions or waves because we don't even use like radio that much anymore. Maybe if there's like an advanced society that they're past using radio, like radio waves. My question is, what kind of communication do you think is the most plausible, or like what do you think could be possible?
Well, just to use the reasoning that SETI people, the search for extraterrestrial intelligence, I mean, that's a big project being done by radio astronomers and biologists and such. It's really radio astronomy driven. They've given a lot of thought to this. I guess the question is, are we looking for something that's passive, or are we looking for something that's active? Passive in the sense like we've put out lots of signals, the old I Love Lucy's that were broadcast openly over airwaves, and slowly there's a expanding sphere, a bubble of those signals that becomes more and more diffuse, following the inverse square law as this thing expands out into space. That kind of stuff, that passive stuff, is going to be really hard to detect. The hope, I think, is, as I mentioned, where we sent the signal out from Arecibo, we're really looking for those kind of signals. And there's some logical places, if you're going to do that, there's some logical places to place that signal. That sort of sits right above the UHF and VHF frequencies in a kind of a quiet spot, because there's natural radio signals that hydrogen, as it does its transitions, the atomic transitions, it gives off radio signals and at 21 centimeter wavelength. And so there's wavelengths where the universe is really noisy, thanks to stars and gases and that sort of thing. But there's something known as the water hole. And right near that water hole that sits above UHF and VHF, that's a really quiet spot. And so that's one of the places where the search for alien signals has been focused. It also does, by chance, sit right above, kind of technologies are probably going to develop along parallel lines to ours. They're probably going to discover wind power before they discover nuclear power, that kind of thing. So, our hope is that if we're going to find somebody, we're kind of looking where we're sort of looking under. It's like the old joke about the drunk searching for his key at night. He's going to look under the light, not like out in the shadows. And we're kind of doing the same thing there. But there's a lot of thought. The bottom line here, there's a lot of thought going into the search. It's not just like, well, let's just randomly listen and see if we get lucky. We're trying to optimize that search, especially given the scant resources, the financial that go into these projects. We're trying to optimize the search. And we're using the world's largest telescopes to do it. Maybe later today they'll find a signal. But today, other than one signal that's never been explained, that was just a short burst and never duplicated, so probably it was just something, wacky and wild and random. The famous wow signal. Other than that, we've found nothing. Does that answer your question?
Yes, it does. Thank you.
Well, you're welcome. Any other questions? Anything else? Well, I hope you've enjoyed the presentation. Again, check out these resources, especially if you go over, when you're on YouTube, just type in the search bar Mick West and go and just look through. He does a lot of stuff. He does a lot of interviews. This guy is real open-minded, by the way. He's not like some snarly old skeptic. No, I mean, nobody'd be happier, I think, than him, given the time he has spent looking at this stuff, to have a real UFO land in his front yard like that old couple in the cartoon. and he interviews all these, all the people with the big flap that's going on right now. He interviews them all, and he does not grill them. He lets them have their say. Now he'll point out where he thinks they're wrong, but he does it in a really reasonable. It's conversational. It's not it's not adversarial at all. So check out Mick West's YouTube channel. Lots of interviews, as well as him looking at lots and lots of things. Those flying, I love those flying pyramids. First time I saw that video, it was on NBC actually, on their morning show. I saw that video, and I said to my wife, I said, look at the way those things are blinking. It's exactly like the navigational lights on an airplane. And it is. There's a set rate. It's the FAA sets the rate at which the various lights on the plane blink. And the blinking all matches the FAA rates. And it turns out that that's a night camera out of focus. It's what they call bokeh, or my daughter who speaks Japanese insists it should be said bokeh. But when you see, when on a TV show, a movie where they focus on the heroine or whoever, and in the background there's all these lights that are out of focus, and they make these pretty little like circles, or well, those shapes depend on the aperture of the camera lens. And I mean, I've seen where on purpose they were heart-shaped or diamond-shaped or whatever. And it turns out that the night vision camera that was used to film that, and it was just a handheld night vision camera with an iPhone attached to it. And you can actually see them adjusting it if you watch the video in its entirety. You can see the edges of the camera where the eyepiece is, the little rubber cup. Anyways, when they're using that night vision camera, it turns out that particular night vision camera has a triangular, and I've seen pictures of the lens of the camera. It has a triangular aperture. The little part of the lens that opens and closes adjusts for brightness. And what happened in that video is the objects are out of focus. They're looking at an airplane. They were right under the flight path into LAX, by the way, wouldn't you know? It was the camera's out of focus. And so what you're seeing is the bokeh of the plane lights as 747. They've even identified which, because they knew the time and the location, and they look at the flight paths of the planes going to LAX. And it was a 747 flying into LAX that is the famous flying pyramid. So, I mean, it's fascinating though, in a way. Okay, yeah, it's not aliens, but it's kind of fascinating figuring out what these things really are. Of course, more often than not, we have so little information. We don't know the time or the locations or what have you. We have so little information to work with that. Like if you said to me, oh, well, 10 years ago, I saw some bright thing in the sky, look in some direction or another. What am I to do with that? Yeah, I mean, it could have been, it could have been my cat, Gigi. Remember that Kiki's delivery service? I have a black cat named after the cat from the Kiki movie. So Gigi, it could be Gigi flying with Kiki, making a delivery. I don't know. Well, any other questions?
I think that's all. We're pretty far over, so thank you for coming and taking the time to talk to us today, Tom.
Oh, you're welcome. I thoroughly enjoyed it.
Good. So I'll go ahead and end the session.